Now, when we talk about compound interest, let's do a quick review of the information that we studied before. We took a look at simple interest. Now, simple interest is basically interest paid on the starting amount, the principal of a loan. So imagine if we start here and we have a 10% increase. So what we do is we take that interest and we tack it onto the total amount of money, and we do that over and over and over again. So we end up with something that looks like a straight line. So please remember that when we're talking about simple interest, we're talking about a straight line. It only grows in a gradual progression. Now, when we talk about compound interest is similar to what we studied before. Y equals ab to the x, where the a value is the p, the b value is what we find in the bracket here, between here and here. That is what our b is, and we can guarantee that this b value is bigger than 1 consistently, so it's going to be growing. So if you think about it, imagine you had a bank account. You put your money in the bank account and the bank gives you interest daily. That money will grow over time if you do not change it. You just don't change the amount that you started with. So what happens is, as time goes on, the bank gives you more and more money, and then that money gets tacked on to more money, and then each time there's a new percentage increase, it's based on the previous amount. Now, let's talk about this basic equation we have here. A equals P 1 plus I to the N. What you're going to be doing is we're going to go and make sure that we understand what each of these variables mean. When we talk about the compound interest, A deals with the accumulated amount. You could also look at this as the future value or the final amount. When we talk about P, we're talking about the principal. When we're talking about that, we're really talking about the start or the A value in our equation for y equals a b to the x. Now, onto the variable I in our equation. I represents we're talking about the interest rate per compounding period, and we'll talk about that as time goes on. But you'll notice that if we put something that was in a compounding bank account, we have something that looks very familiar. You'll notice that, like before, we have our starting amount, and then it increases rapidly over time. And this is how much people make money in banks. They hope for compounded interest. Now let's talk about N. N represents the number of compounding periods. We usually take some composition of yearly time and multiply by a compounding factor. And we'll talk about that in the next part of this lesson. Now, let's go on to the ideas of compounding frequency terminology for I and N. So, when you talk about something that is compounding, compounding annually, we do nothing to that number. We either leave the rate alone or we leave the number of compounding periods, the N value, alone. Now, when we're talking about semi-annual, this means that the information compounds twice over an entire year. If it's quarterly, it's 4. If it's monthly, there are 12 times. Semi-monthly means there are 24 times. Bi-weekly, if you think about it, if we did weekly, it would be 52 2 weeks. But if we did bi-weekly, we essentially cut that in half and we end up with 26 times that happens in a year. Now, the main concept we're going to be taking a look at here are these two things. We take the I value. The I value is the rate or the percentage as a decimal divided by the compounding period that we choose. And then for the N, we take the number of years and multiply by the compounding period. So let's go and practice that right now. We need to be able to calculate or set up the fraction of the interest first, and then we'll figure out the number of compounding periods per period. Now, let's practice calculating the interest rate using the different terminology that we used before. So let's say I have something that is compounded semi-annually at 6%. Well, that's 0.06 is the percentage as a decimal, and then we divide by 12. Now, computing our number, we're going to get something like this. 0.005. Now, here is the deal. You have a choice of using this in your equation or this in your equation. Both can be used. I tend to use this in my equation in order to cut down on the lack of accuracy, because sometimes we end up having to round. Now 5% weekly looks like this. Now the 0.096 is an approximate representation of that number. Now what I would say to you is I would use this number for our calculation. Now I'm going to show you how you round it nicely. Let's say that the answer comes to 0.96153. What you need to look for is a high number like a 6 and a low number like a 1. And you use those two numbers to actually split this list here, and that will be our approximate number that we can use in our calculations. So I would say this could be used for our rounding purposes. The same thing can be done for quarterly when you have 5.2%. And we're done. Now let's move on to the last topic of the day before we get to our actual calculations. So something that is compounding periods. So we're going to take the years and we're going to multiply normally by the compounding period. So if I have something that is compounded quarterly for 5 years, I'm going to start with n is equal to, well, since it's already in years, all we're going to do is multiply 5, and we're going to multiply it by 4 to give our compounding number of 20. Now, for this other time period that we have here, we have something that's compounded semi-annually for 18 months. And what you want to do is you literally just want to say n is equal to, all right, it's 18 months. Semi-annually means half a year. If I took a look at those half years, I could say that happens every 6 months. So in that case, n is going to be, well, just 3 compounding periods. So this is every 6 months. And we take 18 and we try to find the number of blocks of 18, and it should be 3. Now, another way of looking at this is if I have something that is compounded in 18 months, 18 months is actually 1.5 years. And what we're going to do is we're going to take that 1.5 years and we're going to multiply it by 2 since it happens twice in 1 year. And that gives us an answer of n is equal to 3, which is what we expect. Now, you could have done this by taking n equaling 18 divided by 6 to give us an n value of 3 in that case. Alright, now if I have something that's compounded bi-weekly for 6 months, in this case, what you're going to do is you're going to take n, and in order to get something that's done bi-weekly for 6 months, what we need to do is we need to take 6 over 12, which is 6 months, converted into a year. Then what we do is we're going to times that by, well, you guessed it, 26, because bi-weekly means there's 26 periods throughout the year, which means our n value in this case is going to be 13, and we're done.